Your grades? Do it. I put it up this morning. So speaking of the test, the average was much better for this one. So we got up to about a 79, which is a pretty huge improvement over the last one. And what was cool, some people, so like, here's a list of some names, just joking. So improvements for certain unnamed individuals. One person improved their score from the first test to the second by 44 points. It's pretty impressive. And then we had a person that did 30, 20, 20, 16. So a lot of people really turned things around. And they're probably, just more used to the class, studying more, using the study guide, quizzing themselves. If you didn't improve, definitely need to start changing what you're doing, starting like now. So if you bomb the first two, you don't change anything. What do you think is going to happen on the next couple tests? Same thing. So as a reminder, I do have office hours, 10 hours a week. Y'all can come by if you're stuck on anything. Very underutilized. Usually no one comes. And that's just boring for me. I just sit there. Then I end up doing, wasting time things like playing Candy Crush on my phone. I know. You would think I would use that time to do something useful. But, like post PowerPoint. Yeah, exactly. So anyways, that's the exam stuff. If we have time on Monday after the lab, which lab's pretty short on Monday, we have a lab practical, don't forget. Did y'all get that email? It's on that schedule, but I did post a study guide for that, so you can get to studying this weekend. I guess that's it. Is nobody's test grade up there?
It didn't notify us, but it's in the grades. No, I'm in my grade and it's not in there. Really? Oh, I guess.
Oh, if you're looking under quizzes, it won't be there because it was a paper test. So you have to go to grades. Okay, we'll look after class. I don't know how it's possible it's showing up for some people, not for others. It's very strange. All right, so any questions on the study guide from part 2? Yeah, so it's a really common one that people get mixed up. So tendons go between muscles and bone. Ligaments go between bone and bone. So if you remember when we did your chicken thigh dissection, you pulled on the muscles and there was that white strip at the end of it you could cut and it was really silky and kind of smooth. That was your tendon. And then when you cut into the knee really far, you found those ligaments between the bones. They were holding them together, and they're really strong. If you remember kind of pulling on them.
Can you go over the temporomandibular?
Yeah, so your temporomandibular joint. Anybody know where that is? It's this one. Has anyone heard of TMJ pain before? So that's that joint's overactive from grinding your teeth. Yeah, so it's between your jawbones way back here. I will go over any ones you want me to. I don't think I'm going to go over every single one. What are the first 4? So intervertebral is between 2 vertebrae. So you've got a lot of those, right, up and down your back. Okay. And so one trick for all these joints is a lot of times they've got in the name what they're between. So what two things do you think a vertebrocostal is? Vertebrae and then the costal cartilage of the ribs, right? That's the costal part. Some of them aren't always that easy, but most of them will help you. What about the third one? What's the third one? So sternocostal. What do you think that one is? Sternum in the ribs or the costal cartilage? Oh, I guess we could point them out here. So sternocostal is like between here and here. These little things are the cartilage. And for whatever reason, they have it fused here, which isn't quite accurate, right? Because really it's the joints right here. And then the vertebrocostal is back here in the back, in the vertebrae and the rib. On the back. And the last one, or the fourth one. So lumbosacral, where do you think that one is? So there's your sacrum, the last lumbar vertebrae, and the sacrum. That joint's the lumbosacral. At the bottom there. So it's kind of an intervertebral joint, but because it's the sacrum and it's so different, they gave it its own name down there.
Like I understand like where it is, but what does acromion mean? Like what's the like?
I don't know.
Because it says like acromion of scapula and I just didn't like I understand where those.
Yeah, I don't know what the root is for. I don't know why it's called that. It's a good question. I'll have to look that up. Yeah. All right. 1 and 2. All right, y'all ready? Yes, sir. Oh, thanks. Trapped in the middle. All right, so we'll pass those on up. Thanks. Change here. All right, so it's impressive you asked about every joint that was actually on here. Good job. Probably improved everyone's score quite a bit. Let's see, so which type of joint moves in one plane only? So uniaxial, there's that prefix una, one, bi, two, multi, more than two. And what do ligaments attach? It's bones to bones. And what joint is between a rib and a vertebrae? Lumbosacral, vertebrocostal, intervertebral, or sternocostal. So it's vertebrocostal back there. Between the rib and the sternum. It's the sternocostal. And what joint is between two vertebrae? Intervertebral. All right, there's some joints for us. All right, let me go grab that PowerPoint for y'all, and we'll start. All right, I didn't get answer keys ready either. Primary is genetic. I don't know. All right. Here's my pile. All right. So yeah, if you have one, don't take one. All right, you've even got the color one. All right, and if you haven't been printing out PowerPoints to take notes on, maybe this will be a good practice for you. Maybe you'll see that it works better. All right, so our first slide here, we're not going to go through all of them, but I just wanted to remind you this is here. So that's the first slide, you click on it, and then if you click on synovial joints and specific ones, it'll tell you where all the joints are on this diagram. So if you're struggling with some of those, they're nicely labeled and zoomed in. So for example, our vertebrocostal, you can see it zoomed in there between the vertebrae and the rib, highlighted in blue. Maybe you're not sure where the sacroiliac joint is, which, is that even on the study guide? I can't remember. Okay, so that's between the sacrum and the iliac of the hip. So it's labeled right there. So this is a good kind of, it's nice because it's all in the same picture, zooms in, really get a good idea where they all are. But I don't think you need me to go through all those. This is pretty obvious, just take some practice. All right, so we've got, I guess I should say part 2, we're basically only talking about synovial joints today. They're the most numerous, and also there's the most kind of different kinds. And we've got uniaxial, biaxial, multiaxial, and then 6 main types based on how the shape of the bones basically that go together. And they're ranked here from least to most mobile. So we've got plane, hinge, pivot, condylar, saddle, and ball and socket. And we'll go through each one and we'll kind of try to move them in our bodies, which will be fun. And so different things that affect how much these joints move that we'll be testing out. The first one, and the most important, is the shape of the bones that are touching each other. So that's like the primary thing that determines, if you think about moving your fingers compared to like moving your head, like you can't move it as much. That's probably mostly because the shape of the bones that are beating each other. And we'll be going into that. Also, how tight those ligaments are. So if your ligaments are loose, do you think you have more or less movement? Right? So if they're less tight, they have more movement. And actually, that's the main reason for people being double jointed. Their ligaments are a little looser. They don't actually have extra joints. That would be really crazy. Instead, it's just looser ligaments. Kind of interesting. The muscles, soft tissue, this one usually confuses people. And basically that means something else in your body gets in the way. So can you think of an example? That would be one thing, but something bigger than that that's always there. Yeah. So your elbow, it could keep going this way, but my massive bicep is in the way. I just can't keep going. Goodness. All right, I'm embarrassing myself. Also, hormones affected. So does anyone know the pregnancy hormone that relaxes your joints? It is relaxin, which is kind of cool. So relaxin relaxes ligaments of the joints, makes everything a little looser. And it's somewhat surprising because really it's, mostly for during birth, but it's produced very early on. So if you're doing exercise or yoga or anything, they'll tell you, don't do this exercise, don't do it too far, because you can really easily sprain things a lot easier than you would normally because everything's loosened up in there. That's probably because it was, yeah? Huh. Wonder if that's from the relaxants. Interesting. Well, of course, once you're a little more pregnant, other thing gets in the way, right? Some other stuff. All right. Also, just simple disuse could make things less mobile. So, and that would affect, the ligaments, probably the muscles as well. If it's just not moving, things kind of atrophy. All right, so let's start, and we'll stick to least mobile to most mobile. So first one's our plane joints. That's plane, not the other kind of plane. And the main ones in here are the bones of your wrist and your ankle. So first, can y'all move your wrist to wrist? So what you're actually doing there is not your wrist bones, because you've got 6 of them. That's actually the bones of the hand. So your wrist bones, you actually can't even hardly move them in relation to each other. I mean, you can that's still your hand bones, it's not your wrist bones either. They kind of slide each other a little bit, but you can hardly tell that they're moving. Same thing with your ankle bones there. So what are your wrist bones again? What are they called? Carpals. And what was up here? So most of that movement is between the carpals and the metacarpals. That joint, the carpals and the carpals, right they aren't really moving very much, just a little bit. And it's hard to demonstrate because it's such little movement, you can't really tell it's moving. And I guess, do you all know what the prefix inter means? So between. So you see a lot of joints called like inter or something, between. So intercarpal is between the carpal bones. Oh, and the shape of those is basically just two flat bones touching each other. The plane. So two flat planes. And then we've got our hinge joints. So this is like your knee and elbow. And we've got a convex fitting into a concave. Depression. So what's convex again? We're drawing it. Right? So convex is like this. And then the second one is more like that. So that's your elbow and your knee and the joints between your phalanges. And if you notice, which directions can you move your elbow? Is it only one? Even if you turn your hand this way, it's still only one. Is this moving at your elbow, this movement? This is your shoulder. So the only thing your elbow really does is one plane, forearm getting close to the upper arm. That's it. And so even though it can go pretty far, we say it's not that mobile because it's one plane. That's why it ends up second here. Right. Then we have a pivot joint. So this one's kind of complicated, and it's one bone rotates around another. And the best example of this is the proximal radial-ulnar joint, which is between which two bones do you think? Radius and the ulna. So if you're like this and you're doing pronation, these bones are rotating a little bit in relation to each other.
So I had a teacher who, her radius and ulna were fused together.
Okay.
And so would that would she not have that? Because she couldn't move her hand, she couldn't.
So what was her hand like? What did it look like then?
It looked normal.
She couldn't do this? Huh. At all or just a little bit? So her hand was always like this?
Yeah. And
That's
when
crazy.
she would write with her hand, she couldn't bend it. She was always
Huh. Well, you'd be able to move your wrist because this joint is up here.
she would wave at us and be she would wave
Huh.
stupid.
Interesting. Wow.
Her radius and ulnar were fused. She only had one bone. She couldn't they don't overlap or anything.
Mm-hmm. So it was fused all the way down, not just up at the top. Yeah, that's pretty crazy. Huh. Well, anyways, yeah, without that joint, you aren't able to make this movement. So we would call that a pivot joint. So it's a rounded surface, fits into a ring of ligament. And we are going to be zooming on the elbow today, so we'll be seeing that joint in a video and animation to be able to see it better. Because I know those words don't mean a lot at the moment. Great. We also have our condylar, which is biaxial. So it's a convex surface articulating with a concave surface. And one example of that is your metacarpal phalanges joints, which is what? Where's that? So it's like here, right? So you could see which two planes can you move your fingers in comparison to your hands? How can you move your fingers in relation to your hands? So flexion, extension, is there any other way you could move them? Abduction, adduction, so that's your two axes. So we got this one, we got this one. So that's your condylar, example of your condylar joints. Same thing down in your feet, right? Between your toes and your feet. Similar joint down there. It's just, can't move your feet, you know. Can't move your toes quite as well as your fingers. And then we have an interesting one where we have two saddles going on each other. This gives you lots of range of motion. And the best example of that is the first joint of your thumb here, connecting to your hand. So would you say, can you move your thumb more than you can move your fingers? In more directions and maybe a little farther too? I think so. It still was only biaxial though, our thumb joint. So our last one is our ball and socket joint. I think people tend to think all your joints are ball and socket joints, but they're not. Your two main ball and socket joints are your hip and your shoulder. So I don't remember how many people actually looked at the hip and the chicken thigh. I know all I told you had to do was the knee, but if you looked at the hip, you'd see that ball and socket, where you actually have a ball of one fading into like sort of a deep socket of the other. There's the only ones I can think of, but I hate to say there's not any, because there's a lot of joints. Those are the only ones I can think of, though. Mm-hmm. So I know if you're like at the chiropractor, usually they say it's like air pockets in there from the popping. That's what they say. I don't think anyone knows for sure. Yeah, but I'm not sure they know for sure. I actually tried to look it up, and there's not true definitive answers for why those pops happen. I guess. I don't know. I'm just surprised, 'cause I think I would agree with you. You would think we would know what that popping is from.
So in the book, it mentions something about like joints just cracking in the hand or something like that, but it's air pockets. But chronically, you know.
Yeah. But I have read that that's not completely proven. It could be other things. And certainly there's different from popping, right? Like if you ever felt like something kind of tug and then it kind of gives sort of thing, that's like ligaments kind of wrapping around each other, or because you saw that knee joint, like how much stuff was in there. So you could imagine one of them getting stuck against one ligament against another, and then just finally it comes free around the other one. So let's go ahead and we could just demonstrate at the moment. 3 planes you can move your arm in. So we got one out here, right? We got one out here. And what's the third one? This way. Right? 1 plane, 2 planes, 3 planes. And circumduction, it's not considered its own plane. It's just a movement. But anyways, and of course your hip can do those same planes, just maybe not quite as much, right? You could put your hand out completely side. Can you put your leg all the way out there? If you're very flexible, maybe, but not easily. You certainly can't put your leg, at this angle like you can do your arm, right? That'd be impressive. Should we all try that? All right, so which of these could contribute to a decreased range of motion if you wore a cast for several weeks? Like, for example, on your elbow, like you couldn't move your elbow for a month or something. Anybody else? Is there more people here? 10, 13. All right, so nearly everyone said D there, which is correct. So muscle atrophy, so any of the muscles that you don't use, they do eventually start getting reduced in size. And then also just getting reduced flexibility from those tendons and ligaments. Although, actually, I don't think B is right, now that I read it. What do you think having weaker muscles would do to your joint? Wouldn't it make it weaker and like more flexible? So really, what's the only answer? It's C up there. Reduce flexibility of the tendons and ligaments. So if they're stuck in that one position, they're not being stretched, they kind of tend to harden a little bit. That would be true as well. But in terms of how far you could move it, that wouldn't change. So if we ask the question, why would the joint be weaker, then the answer would be B. What about, do you think synovial fluid changes? Yeah, it would definitely decrease. You'd have less fluid in there. No, you just have less fluid. So like, yeah. Huh, never heard that before. I've always said that it was just the amount of fluid that's in there. And certainly exercise would increase the amount of fluid. But
I think it's more like it's more gel-like when there's less fluid.
right. So I guess we're saying the same thing in a way.
It's the same thing.
All right, so here's another long question for you. I'll let you read it and answer when you're ready. Anybody else? I feel like some of the clickers aren't turned on or something. All right, so we've got lots of F there, some B. So why don't you chat with your group then and you can vote again. final guesses? All right, so the few people that stuck with A, that's the best answer. This may be the first time that more than one of the above was not the answer when it was up there. So at least, thinking about it in simpler terms, the only thing we said was changed was the shape of the bones. Right? So like your ball and socket, maybe your ball got damaged and now it's a square instead of a circle. That wouldn't work as well. Which other ones were you thinking it was?
Or not
B? Oh, D?
I was thinking like soft hard bone and cartilage that like lines those.
Mm-hmm.
The bone takes shape and then the cartilage is reformed.
In general, the soft parts thing is something like outside the joint in the way, like another bone or another part of your body. Certainly you could imagine that something could go wrong with the cartilage in the bone, perhaps, but that's not really part of that question. All right. So what I was going to have you do is kind of combine what we did last time with what you learned today. And so using your own body, I want you to tell me what kind of movements you can do at shoulder, elbow, hip, and knee. So you can just circle all that apply for each joint. So I want to see arms waving around and legs above your heads. Starting. Yep. And if you're not sure, remember go into anatomical position and test it. If you're not sure about one of them. Okay, cool. I know, I'm missing a lot of people today. 1, 2. So your elbow is just where it attaches. Up.
Where it attaches to your leg.
Yeah.
When you rotate like this, that's your radial ulnar joint, not your elbow, right?
Right. And actually, a lot of that's your shoulder, right?
Is it more? Is it both? Okay, so it's not.
Not for the elbow.
Still your shoulder.
It's like, well, abduction, like adding to the body.
Elbow probably. So yeah, our elbow can go out or nothing. It's tricky.
I know.
Not
It's trickier than it seems.
well, I'm pretty sure your knee doesn't rotate because that's something you should. For your knee. Like she was saying,
That's what I meant.
you'll be able to hyperextend too, right? Oh, actually, no, you cannot. Your leg, you can't hyperextend.
1 minute.
Your hips like the shoulder. That's what they did.
I felt for the hip, I did all of them.
All right. Does everybody think they have an idea for those? All the groups got some stuff down? All right. Why don't we start with this group in the front? Pager in here. What did y'all say for the shoulder? Yeah, it is all of them, definitely. What about group behind y'all? Let's bring you back there. What did y'all say for the elbow? Yeah. That would be it, definitely. All right, and then what about hip up here in the front? 3J. Is all of them. And then what y'all say for the last one? Yeah, your group back there. So just flexion and extension for the knee. Which other one did y'all think it was? How does that look like? So you can move these lower bones in relation to your femur? Can you? I can't. Come over here. Yeah. I think it's your hip more than you think. It can, I mean, okay, we could say your knee does let you do a little bit of rotation, a tiny bit. But don't get yourself too confused because most of that rotation is still your hip turning. But you're right, maybe a little bit in the knee, just not much. All right. All right, so I just picked out a few joints to talk a little more in detail about. So the first one is your shoulder joint. And to try to be more specific, when we say shoulder, what we're talking about is where your humerus meets your scapula. So like right up there, that's your actual shoulder joint. So is the clavicle involved in the shoulder joint? Not really. If we're just being specific, the shoulder joint is just where those two bones meet up there. Even though the clavicle's close, that's the different joints, different parts. So if you notice, it gives you the greatest range of motion of any of your joints. And because of that, it's the most unstable, and it's the most commonly dislocated joint in your body. And that's because if you're a joint that lets you have lots of movement, that also means it's easier for it to be moved too far and get dislocated. I haven't seen any studies on that, but it makes sense that it would be so. But I think one thing with people that are more flexible, they're also probably strengthening those muscles at the same time. So maybe that would counteract the looser sort of ligaments that you're stretched out. And actually your shoulder, there's some ligaments, but the main thing that's holding it together is the rotator cuff muscles, which obviously don't hold things quite as well as super tight ligament. We'll watch a little animation on here. Let's see what all that looks like. So from 2 minutes. Am I crazy for not seeing anything up there? Where? Let's try different web browser instead. I don't. Do you feel like you would want a review of synovial joints in general? That'd be helpful. I think we have the time. That's what the first 2 minutes are.
Greatest range of motion of any joint in the body. However, this large range of motion can also be shoulder problems. Understanding the different parts of the shoulder can help you understand how the shoulder works, how it can be injured, and how challenging recovery can be when the shoulder is injured. The important structures of the shoulder can be divided into several categories. These include bones, joints, ligaments, tendons, muscles, nerves, blood vessels, and bursa. The bones of the shoulder are the humerus, or the upper arm bone, the scapula, or the shoulder blade, and the clavicle, or the collarbone.
So he's including it. Most people don't, but it's okay.
Called the acromion. There are actually 4 joints that make up the shoulder. The main shoulder joint, called the glenohumeral joint, is formed where the ball of the humerus fits into a shallow socket of the scapula. This shallow socket is called a glenoid. The acromioclavicular, or AC joint, is where the clavicle meets the acromion. The sternoclavicular, or SC joint, supports the connection of the arms and shoulders to the main skeleton on the front of the chest. The false joint is formed where the shoulder blade glides against the rib cage. This joint, called the scapulothoracic joint, is important because it requires that the muscles surrounding the shoulder blade work together to keep the socket properly aligned during shoulder movement. Articular cartilage is the material that covers the ends of the bones of any synovial joint. Articular cartilage is about 1/4 of an inch thick in most large weight-bearing joints. It is a bit thinner in joints such as the shoulder, which don't normally support weight. Articular cartilage has a rubbery system. It's very slippery, which allows the joint surfaces to slide against one another with very little friction. Articular cartilage functions to absorb shock and provide an extremely smooth surface to make motion. There are several important ligaments in the shoulder. Ligaments are soft tissue structures that connect bones to bones. The joint capsule is a watertight sac that surrounds it. In the shoulder, the joint capsule is formed by a group of ligaments that connect the humerus to the glenoid. These ligaments are the main source of stability for the shoulder. They help hold the shoulder in place and keep it dislocated. Ligaments attach the clavicle to the acromion and the AC joint. Two ligaments connect the clavicle to the scapula by attaching to the coracoid fossa, a bony knob that sticks out of the scapula in the front of the shoulder. A special type of ligament forms a unique structure inside the shoulder called the labrum. The labrum is attached almost completely around the edge of the glenoid. When viewed in cross-section, the labrum is wedge-shaped.
So that's in purple there. So you've got, what do you think is in this whiter part? What's that? Yeah, so it's the cartilage, and then outside of it a little bit, a little extra like rim is the labrum.
The wedge shape, the way the labrum is attached, creates an elevated rim around the glenoid socket. This is important because the glenoid socket is so flat and shallow that the ball of the humerus does not fit tightly. The labrum creates a deeper cup for the ball of the humerus to fit into. The labrum is also where the biceps tendon attaches to the glenoid. Tendons are much like ligaments, except that tendons attach muscles to bones. Muscles move the bone by pulling on the tendons. The biceps tendon runs from the biceps muscle across the front of the shoulder to the glenoid. At the very top of the glenoid, the biceps tendon attaches to the bone and actually becomes part of the labrum. This connection can be a source of problems when the biceps tendon is damaged and pulls away from its attachment to the glenoid. Four tendons connect the deepest layer of muscles, the rotator cuff muscles, to the humerus. Just before these muscles attach to the upper end of the humerus, they join together to form a single tendon called the rotator cuff. The rotator cuff muscles lie just outside the shoulder. These muscles help raise the arm to the side and rotate the shoulder in many directions. The rotator cuff muscles and tendons also help keep the shoulder joint stable by contracting and holding the humeral head tightly in the glenoid socket as the humerus moves. The large deltoid muscle forms the outer layer of the shoulder muscle. The deltoid is the largest, strongest muscle in the shoulder. The deltoid muscle provides the power to lift the arm once the arm is away from the side.
All right, I think that's plenty of info about the shoulder, don't you think? So you can imagine for the shoulder dislocation, you don't snap those ligaments or tendons or anything. It's just that bone doesn't fit, that socket isn't all that deep, so it's very easy for it to just pop out a little bit. Has anyone put a shoulder back in socket before? Anything? What? It would be. I wish I had done it. Apparently, it's really common for especially like little kids, like 1-year-olds, 2-year-olds. One of our neighbors had their little boy's shoulder came out of socket, and she brought him in, and they actually showed her how to do it for next time. A kid, I'm sure. I mean, it takes more force for an adult because there's so much more stuff there for little kids. It's like, do it. I mean, for a kid, I don't know. I mean, there's lots, any kind of incorrect force, too much pulling on a certain part, falling on it. Has anyone had a dislocated shoulder? You can tell us what did you do to dislocate it? Just like, so it got pushed from behind, kind of? Yeah. So is weight from above, like this way? Yeah. Well, it kind of makes sense though, because they would just push the bone right down, right? Just pop it out. And then, just like you dislocate any bone, they just pop it back in there. It's probably going to hurt, be sore, because, those muscles were stretched way too much. But nothing's permanently damaged in there, or at least it shouldn't be. It's not like tearing a ligament or completely tearing a muscle or something. All right. So which of these contributes the most to keeping the head of the humerus in the glenoid cavity? Do you think? Channel 1. Maybe that's why we're not getting all our votes. All right. So we've got C, D, E. So why don't you chat with your group there, and then we'll vote again. All right, final answers. All right, so we got C and E. So if we're talking about the most, it is actually the muscles, the rotator cuff. So the ligaments hold the bones together, but without the muscle there, it would just kind of be very easy for it just to pop down a little bit, just because of gravity and how the ligaments are. All right. So next up is our elbow joint. So one thing to notice is when we say we're talking about the elbow joint, at least I think this video is also going to extend it a little bit too much, but technically it's only the ulna meeting the radius and the humerus meeting the radius as well. So the radial ulnar joint that we were talking about, that's not quite part of the elbow technically, but we'll still look at it because it's pretty close to it. And of course, keeping the two joints separate, humeral-ulnar, that's the humerus and the ulna, humeroradial, that's the humerus and the radius, just right there in the name. All right, so obviously tons of ligaments in there. Here's the humerus, here's the ulna, there's the radius. One thing to notice, you do have this, well, it doesn't really matter. We're going to go into each of these different ligaments and see what they do. Just for fun. So we'll focus on these three ligaments. The first is the ulnar, or also known as the medial collateral ligament. And if you notice, do you have that ligament in your knee? the MCL. So for a lot of these, they'll be same name but different ligaments in different places because it's a very similar joint. So they just gave them the same name. So that one attaches the humerus to the ulna. Then we have the radial or lateral collateral, which attaches the humerus to the radius. And then we'll look at this last one, even though it's not really part of the elbow, but to give you an example of that special type of joint we had earlier. So ulna to radius. I'll go ahead and put these up here so when we look at the movie we can know what we're talking about. Ulnar. So this one. Lateral. All right. First 4 minutes. Let's look at the elbow.
At first, the elbow seems to work like a simple hinge.
Do you know this is the only video I've ever found with a southern accent for all the anatomy videos? It's kind of fun.
The elbow is a complex joint whose motion affects the forearm and the wrist joint. It is easy to see why the elbow can cause problems when it does not function correctly. Part of what makes us human is the way we are able to use our hands. Effective use of our hand requires a stable, painless elbow joint. The important structures of the elbow can be divided into several categories. These include bones, joints, ligaments, tendons, muscles, nerves, and blood vessels. The bones of the elbow include the humerus, or the upper arm bone, the ulna, the larger bone of the forearm, on the opposite side of the bone, and the radius, the smaller bone of the forearm, on the same side of the bone. The elbow itself is essentially a hinge joint, meaning it bends and straightens like a hinge. But there is a second joint where the end of the radius, or the radial head, meets the humerus. This joint is complicated because the radius has to rotate as you turn your hand palm up and palm down, while at the same time it has to slide against the end of the humerus as the elbow bends and straightens. To make this motion possible, the radial head is shaped like a smooth knob with a shallow cup at the end. This shallow cup fits against the capitellum, the rounded knob at the end of the humerus that forms part of the elbow. The smooth rim of the radial head is also covered with articular cartilage that glides against a small indentation in the ulna. Articular cartilage is the material that covers the ends of the bones of any joint.
Yeah, we know about that.
Cartilage can, there are several important ligaments in the elbow. Ligaments are soft tissue structures that connect bones to bones. The ligaments around the joint are connected with a thin layer of connective tissue and form a structure called a joint capsule. The joint capsule is a watertight sac that surrounds the joint and contains lubricating fluid called synovium. In the elbow, two of the most important ligaments are the medial collateral ligament and the lateral ligament. The medial collateral ligament is on the inside edge of the elbow. The lateral collateral ligament is on the outside edge. Together,
So inside or outside, how are you holding your hand, do you think? So if you're anatomical, where's your medial then? If you're like this. It's on the inside. Right?
these two ligaments connect the humerus to the ulna and keep it tightly in place as it slides through the groove at the end of the humerus. These ligaments are the main source of stability. They can be torn when there is an injury or dislocation. If they do not heal correctly, the elbow can be too loose or unstable.
Isn't that kind of interesting? Got this little circular ligament and lets it move that way.
This ligament can be torn when the entire elbow or just the radial head is dislocated.
So there's those ligaments. Just give an example of where they all are. All right, so if you had to guess, why is it that your shoulder can move more than your elbow based on those movies you're watching and everything? All right. So I'll have you talk to your group there, and I'll tell you, since it does say primary, you can't say more than one of the above. You're going to have to choose one of those first 5 answers. If you had to choose one thing, what would it be? This isn't very good. All right, something's wrong there. If you're bored, Andrew's showing us how you can spin his whole arm around somehow. It's a lot of rotation. So anyways, the answer for this one is A. If you had to pick one thing, it'd be the shape of the bones. All right, settle down. Just a few more things to do. So we got our hip joint. Right there. Got it in our skeleton down here. And you can see that it's a ball and socket joint, but it's a much deeper socket than in your shoulder. So instead of just barely fitting in there, like your shoulder, the femur fits really deep into the hip bone there, which is good because what's your hip bone for? What's your hip bone for? What's different between the joint here and your shoulder joint? So it supports all your weight, right? The shoulders don't support anything. So interesting there. And you can see in this picture, kind of cross section, how deep it is in there. And if you saw it in the chicken thigh too, you would have seen a much deeper, a pretty deep ball and socket there. All right. So why is the hip joint more stable than the shoulder joint? All right, so most people chose either B or E or F. So I'll let you chat with your neighbors for a moment, and then we can vote again. All right, so final answers. So I would say the best answer is actually B. So it's all because of the deeper socket. And the reason it's not so much the ligaments is the ligaments are just as strong. It's just because the socket's so much deeper, you could pull the ligament 50% farther and the bone's still going to be in its socket, if that makes sense. So, I mean, how often do you hear of dislocated hips? Have you heard of that? I mean, that doesn't usually happen. What's the main thing that goes wrong with the hip, usually, like in older people, elderly? Well, the cartilage goes away, definitely. So it might be painful, or you might actually break it. And most of the time what's breaking is the actually head of the femur is breaking, just because osteoporosis, the bones just aren't as strong. So this joint is so strong that instead of the joint dislocating, the bone breaks. Kind of crazy. So that is good because do you think would you be able to walk with a dislocated hip? Probably not. So thinking about evolutionarily, kind of, you can't have your hip dislocating because then you're done for. And I'm guessing it's probably pretty hard to put it back too. Not like a shoulder. I mean, there's.
Well, like when people, when their hips go out, they say, is that just like is that like the ligament just pulling or something so it's not lining up right, but it's not actually like out of?
I didn't hear the first thing what you said. When what?
When, like my grandma, her
Uh-huh.
hips come out all the time, like they don't, like, yeah, the hips pop out, I mean, not like all the way, but just like she has to go get it like reset, like her, yeah, like one of her legs will come out.
Really? Maybe it is a little dislocated.
Is it your actually, it's not your
What is hip dysplasia in dogs? I'm trying to remember. Yeah.
Where the hip sockets aren't as deep.
So the socket's wrong. That's what I was going to say.
They're more like this.
But like, I guess I'm asking like what causes that to happen in her, is it because her ligaments or her muscles like are too tight and it pulls on it, so it's not actually out, it's just like not fine.
Well, probably some, it could be some of the bone shape, but it could also be the muscles are weaker just because she's older, or the ligaments are looser. Could be lots of stuff. You should
It's obvious.
ask her doctor and see. That's crazy.
I don't know why they can't
All right, so we'll do this last part next time since it's 2:20. Too much. I don't know. I thought this was going to be a quick one. It's okay. Yes, so your lab practical is Monday, which means no lab quiz. But you do, no online lab quiz, but you do have your lab practical Monday.